Hi all, this is Mr. Yeager for chemistry, introducing the atom and the structure of the atom today. So what we're going to be looking at is basically the particles within the atom, identifying the different parts of the atom and the particles involved and all the properties of those particles. We're going to name and identify elements, and then in a separate video we're going to run into isotopes. Okay? So what is the atom? The atom is matter. So we covered matter already. The atom is that smallest unit of matter, but it has all the same properties, both physical and chemical, as the macro object itself, the one that you see, the macroscopic. Atoms are submicroscopic particles, so we cannot see them with microscopes. We obviously have other ways we can try to see them, but what we see in real life, it would be the exact same thing we see at the atomic level as well. So I have the gold atom over here on the left in atomic form. Okay, this is gold in terms of all of its particles and what it basically forms. And this gold atom looks exactly like the gold on the other side, the golden bars. Okay, it would have all the same properties, all the same reactivity as gold does, all the same conductive capabilities as gold does, etc., etc. So it doesn't matter what the size of it is, it's still going to be the same. So, what are the different parts of the atom? Okay, we have the nucleus. All right, the nucleus is small but very, very, very dense, and we're going to learn that it is positively charged. So, the nucleus is the part inside here. Okay, it is the center, what we would consider to be the center of the atom itself, but it is very, 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 very tiny. Okay, it's actually very difficult for us to try to interact with the atom itself, or sorry, the nucleus itself, because it is surrounded by those electrons. When we interact with atoms, we are primarily interacting with what's called the electron cloud or the energy levels, the electron energy levels. All right. Clearly, that's where the electrons are located. That's outside the nucleus, not outside the atom. The thing is, most of the atom is actually empty space. All right? There's a lot of distance between the nucleus and the electrons, and even the electrons in the different energy levels. Okay? So one more time, this is the nucleus on the inside. It does have a positive charge. We're going to learn why in a moment. You can kind of see that in some of the key on the side, except that I couldn't spell positive or correctly, so that's positive. Okay? And then the rest of the atom on the outside here would be what we call the electron cloud. Okay? We call it the cloud because, again, the electrons are moving everywhere throughout it. We don't exactly know where they are, but they're in this general space. Both of these things together, the nucleus and the electron cloud, is the atom. Okay, that makes up what the atom is. Once you leave the electron cloud, now you're outside the atom. All right. So, what are the different particles in the atom? Okay, starting on the inside. Okay, you can see a little bit. We got the protons. Okay, the big thing about the protons is they are positively charged and they are in the nucleus. All right. They also carry some mass with it. On my next page, I'll give you the exact number for the mass. But the protons do have mass, all right? We do use the protons to help figure out how much the atom has in terms of, I don't want to say weight, but it's molecular mass. The green parts here that have no symbol in the side of them, those are the neutrons, okay? The neutrons, they have no charge. I don't know why I'm putting that in parentheses, but I am, okay? And they are in the nucleus as well. They are important because, as we know from physical science and everything, a positive and a positive will repel. So these protons, they don't necessarily want to be together because they're going to be repulsive with that positive charge. But with the neutral neutrons in between them, those protons can stay together. All right, they can be held together with what we call a strong force. All right, so we have protons that are positive in the nucleus, neutrons that are neutral or no charge in the nucleus. They also have some mass. Okay? They also have some mass. They're actually larger than the proton, just ever so slightly. Outside the nucleus is where we will find the electrons, The electrons have a negative charge. Okay. And again, we say that they are found on energy levels. All right? We're going to try to be more technical here in chemistry because we will break down what energy level they're on, and that's a major part of how we see the atoms, the reactions with the atoms. All right? So the energy levels. The electrons are also particles. They also are matter, but they basically have no mass. I mean, they are, again, they do have a little bit, you'll see that on the next page about how much, but they are very, 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 very small. Much smaller than the protons and the neutrons, where they don't significantly add to the value of the mass at all. All right? But those are our three main particles in the atom itself. So if we break that down again some, the proton has a positive charge. All right? When we eventually really need it, we will say it's a positive 1 charge. And they are found in the nucleus. You can see over here, now I have the mass. The mass of a proton is 1.673 times 10 to the negative 24th grams. Now that is obviously very, 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 very small. Okay? But we will learn eventually how that when we have atoms, we're going to be talking that we have quadrillion, pentillion, hexillion number of atoms, which gets us to basically this negative 24th value, and that'll add up to some mass, okay? Another way we kind of refer to this as is a proton basically has a mass of 1 AMU, okay? Again, that's very generalized. There is a more specific way to talk about how much specifically is an AMU, but a proton basically is 1 atomic mass unit. That's what it stands for, atomic mass unit. A neutron has no charge, is in the nucleus, and you can see is ever so slightly bigger than the proton, 1.675 times 10 to the negative 24th grams. So basically both the proton and neutrons are equal to about 1 AMU. The electrons, negatively charged. If we eventually want to really get clear about it, it's -1. Each one has a -1 charge. They are found in the energy levels or the electron cloud. It's perfectly fine still to kind of say both. All right. And you can see right here, they have a mass of 9.11 times 10 to the negative 28. That is 10,000 times smaller than a proton and a neutron, which is why, even though I might have lots and lots and lots of these, hundreds of, obviously more than that, the amount of mass that they still contribute is extremely small. So we will essentially say that electrons do not, again, significantly contribute to the mass. There's 0 AMU essentially. All right. You don't necessarily need to remember those exact numbers for what the proton, neutron, and electron basically weigh, what their mass is, but it's worth just kind of giving you a visual and understanding about what their size is all about. So what we're trying to get to now is, now that we understand these protons, neutrons, and electrons, how do we then figure out how many protons, neutrons, and electrons are in different elements on the periodic table? And in that way, how can that help me figure out which element I'm talking about? Because if I give you the number of protons, that can tell you which element you have. All right? If I give you objects that actually have the same number of protons but different neutrons, how do I know that they're the same object or different, same element or different elements? So this is going into how do we figure out protons, neutrons, and electrons. What we got to figure out and understand is what's called the chemical symbol, atomic number, atomic mass, and mass number for each element. Okay? And so periodic table is going to help us some things actually on here we can't find on the periodic table. So here's an example. So this is one element on the periodic table. Okay? So if I want to say, okay, what is this element? Now, all periodic tables can be slightly different, but they will all have generally these 4 pieces of information on it. Okay? Just the order that you might find it might be different. Like this number 20 might be over here. You might even see it down low in the 40.078 up top. Don't be overly confused by that. Okay? Everything can still be understood what it means, regardless of where it's placed in the box itself. So what I have here is, very clearly, I have the element name. So I have calcium here. And this right here is the chemical symbol, the Ca. Chemical symbols are always made up of either one or two letters. The first letter is always capitalized. If there is a second letter, that has to be lowercase. Whenever we see a new capital letter, we have to assume when we're reading the elements, especially when we get to compounds, that that is a different element. Okay? But this is a capital C, lowercase a. That's the chemical symbol for calcium. This whole number, okay, no decimal, this is the atomic number. And the atomic number is equal to the number of protons. So every single calcium atom in the world will have 20 protons. If it gets one more or one less, it's no longer calcium. Calcium must have 20 protons. Down at the bottom here, this is known as the atomic mass. Okay? This is not the mass number. We actually have to bring that up a little bit later. Okay? So this is the atomic mass down here. We're going to learn during isotopes a bit more. I'll say it now, though. This is also known as relative atomic mass. It basically is a weighted average of all the different isotopes that are existent. And it's weighted based on which one's more abundant than the other one. We're going to learn isotopes are atoms of the same element, but different number of neutrons. So there's different versions of calcium. They all have 20 protons, but we'll learn that they have different neutrons later on. So that's basically what we have here. Okay, so at least looking at this, I know the name, and I know this has 20 protons. Boom, I know that. I'm done right there. Okay. Let's get another one. This is phosphorus. So again, we got the chemical name, or the elemental name up there, phosphorus. The chemical symbol. The atomic number is 15, and the atomic mass is 30.974 AMUs, whatever you want to call it. All right, so that is another element. So what we're missing here is, and I'll go back even to the prior one, so we can kind of do an example with it, is I never mentioned mass number. Okay, so how can I can figure out the number of protons is 20. But how would I figure out the number of neutrons and electrons in this? All right. At this point in time, we are going to assume that all elements are what's called electrically neutral. All elements are electrically neutral. What that means is the number of protons will equal the number of electrons. All right. They will always equal each other for now. So that means if I know the atomic number is 20, that's the number of protons. That's still what the number of protons is. It just happens to be equal to the number of electrons right now. The thing is, how do I figure out neutrons? I have to give you another piece of information. This is what's missing on the periodic table. Okay? You do not have what's called the mass number, which is equal to the number of protons plus the number of neutrons. And so that is something I have to give you. And this is where, again, where there could be a couple different versions of it. So I'm going to go and let you know. Let's say calcium has a mass number of, I'll write it, mass number of 40. Well, if calcium has a mass number of 40, what we're saying is it has 40 total protons and electrons. Not 40 and 40, 40 total. So if I have 40 as my mass number, and that's the number of protons plus the number of neutrons, and I know I have 20 protons, it's a simple subtraction to solve for the number of neutrons. So 40 minus 20 happens to come out to 20. Now I don't want to get messed up because I have some students that sit here and go, oh, okay, so protons and neutrons are equal to each other. No, please no, okay? It just happens because the mass number is 40 and 20 of those are protons, the other 20 are neutrons. I could have easily said the mass number for calcium was 42. That means the protons is 20 and the neutrons is now 22. Okay? So that's what we got to pay attention to a little bit. So let's do another one with phosphorus. So let's say, for instance, that phosphorus, let's say it has an atomic number, a mass number of 34. A mass number of 34. And I want to know the protons, neutrons, and electrons for phosphorus. Well, right here, 15, what's that? That's the atomic number, and the atomic number is the number of protons. Because I'm assuming that this is electrically neutral for right now, I also have 15 electrons. Then, 34 equals protons plus neutrons. 15 protons. I'm going to subtract the 15. That equals 19. So I have 19 neutrons in this phosphorus. All right? So that is how we are basically doing each of these problems, and that's all we have to look at. Usually, at least at this point, the bottom number is really not that important. It will be very important later. Right now, it's not so important. Okay? Now, there are a couple other ways to look at elements that we are using all year long. You will see it where sometimes you just see the chemical symbol. Whoops, sorry. The chemical symbol and a number after it. Or you might see a chemical symbol and two numbers. Okay? If you see it this first method on the left here, okay? The number after the element is the mass number. Okay? They're giving you the mass number for that element. So I could figure out sodium, which is Na, this is sodium. All right? I can look up sodium and see that the atomic number, it's kind of redundant, isn't it? Atomic number. The atomic number is 11. That means the protons is equal to 11. The electrons is equal to 11. If 23 is the mass number, protons plus neutrons, and this is 11. 11 plus what is 23? The answer there is 12 neutrons. So this is another method to look at elements. Over here, it's a little bit clearer, where now you can hopefully understand the top number is going to be the mass number, and the bottom number is going to be the atomic number. Okay? So you might see that on other elements. Like when we go back to calcium, we could have just written calcium as Ca40 or Ca4020. The top number is always the mass number. The bottom number is always the atomic number. There's never a time that the number written will be the number of neutrons. You'll pretty much always have to solve for the neutrons with some information being given to you. Okay? All right, so going back through it, the chemical symbol, some of the terminology learned is 1 or 2 letters representing the element. The atomic number is the number of protons unique to each element. The atomic mass is the average mass of all the isotopes of the element. The mass number is the sum of protons and neutrons. And then for now, we're assuming number of electrons equals the number of protons, that the element is electrically neutral. All right, so that's pretty much it. Thank you.